All right, let's dive in. Today, we're putting the entire universe on trial. You see, for the better part of a century, astronomers have been piling up evidence for what looks like a cosmic crime scene. The charge? About 85% of the matter that should be in our universe is missing. And we've got two main suspects.
Now, the standard story says the universe is just filled with this invisible stuff called dark matter. But there's a much more radical idea, one that asks a pretty profound question. What if the mystery isn't about some missing substance at all? What if it's about the fundamental force holding everything together? What if our whole understanding of gravity is just plain wrong?
So yeah, this all starts with a very simple observation that completely breaks our known laws of physics. We call it the case of the missing mass. And the crime scene? Well, it's the entire cosmos.
Okay, so check this out. When we look at these beautiful spiral galaxies, we can actually measure how fast the stars way out on the edges are spinning. Now, according to everything we know from Newton and Einstein, those outer stars should be moving way slower than the stars near the center, right? Because that's where all the visible stuff, the stars, the gas, is concentrated. But that's not what we see at all. The stars on the edge are zipping around just as fast as the inner ones, so fast that these galaxies should be ripping themselves apart, but they're not. And this chart just lays the problem out perfectly. The bar on the left, that's the speed we predict based on all the matter we can actually see. And the bar on the right is the speed we actually measure. This isn't a small rounding error, folks. It is a huge, massive discrepancy. There's an incredible amount of gravity coming from somewhere, holding these things together. The question is, where?
So, this brings us to our two main culprits. Is it possible that there's this enormous, invisible halo of dark matter surrounding every galaxy, acting like some kind of extra gravitational glue? Or is it possible our theory of gravity itself is just flawed, that it stops working the way we think it should on these gigantic cosmic scales? Invisible matter or a new law of gravity? That right there is the heart of this entire debate.
For decades now, the scientific community has pretty much put all its chips on one answer: dark matter. It's the reigning champion, it's the absolute cornerstone of our standard model of the universe, what we call Lambda CDM. And the reason is, it doesn't just solve the galaxy spinning problem, it seems to solve almost everything.
So what is this stuff supposed to be? Well, dark matter is this hypothetical substance that's totally invisible. I mean, it doesn't emit light, it doesn't absorb light, it doesn't reflect light, nothing. The thinking is that it's some new kind of particle, something completely outside of our standard model of particle physics. Its one and only job, as far as we can tell, is to have gravity.
And there is supposed to be a ton of it. In the standard model, the stuff we're actually made of, stars, planets, gas, you, me, everything we see, that's only about 5% of the universe. Just 5%. About 25% is supposed to be dark matter, and the rest is an even more mysterious thing called dark energy. So yeah, we only really have a handle on that tiny 5% sliver.
But see, dark matter isn't just some convenient patch for spinning galaxies. It also solves two other massive cosmic problems. First, when we do the math on the Big Bang, it shows there just wasn't enough normal matter created to make the universe we see today. And second, the early universe was incredibly smooth. Dark matter provides the gravitational scaffolding, if you will, that allowed normal matter to start clumping together to form the huge web of galaxies and clusters we see. Without it, we literally can't explain how we got here.
It's a really compelling case, right? The leading suspect for what this particle could be was called the WIMP, the weakly interacting massive particle. It was kind of the perfect candidate. So for more than 30 years, physicists have been building these insanely sensitive detectors deep underground, hoping to catch just one. But after all that time, all that effort, they have found absolutely nothing. Not a single one. And that persistent failure to find anything, well, it's cracked the door wide open for a much more radical idea. It reminds me of that old saying, it's what we know for sure that just ain't so. What if everyone's been looking for the wrong thing this whole time?
Well, this is where the underdog challenger enters the ring. It's a theory called MOND, which stands for Modified Newtonian Dynamics.
MOND's proposal is simple. There is no missing matter. The problem isn't with the stuff in the universe, it's with the law of gravity itself. The idea, first proposed back in 1983, is that while gravity works perfectly in places like our solar system, where accelerations are high, it starts to behave differently. It changes its own rules in the super low acceleration environments out at the edges of galaxies.
And it all comes down to this one tiny number, 10 to the minus 10 meters per second squared.
I mean, that is a ridiculously small acceleration. To put it in perspective, it's about what you'd feel if you accelerated from 0 to 60 miles per hour over the course of an entire year. MOND says that once acceleration drops below this critical point, gravity just gets stronger than we'd expect. And just like that, you get the extra force you need without any dark matter at all.
Okay, so here's where it gets really wild. MOND isn't just some fringe idea. It makes these stunningly precise predictions. The theory predicted the exact relationship between a galaxy's visible mass and its rotation speed. It predicted the behavior of these faint, fluffy galaxies that nobody even thought existed when the theory was written. It even predicts this bizarre thing called the external field effect, which has no explanation in the dark matter model, but which we now seem to be observing. It just keeps getting things right.
So this leaves us with a real galactic showdown. We've got two very different theories on the table. So let's look at the tail of the tape. Which one actually explains the universe better?
And here's the scorecard. When you're talking about the precise, orderly behavior of individual galaxies, MOND wins, hands down. Dark matter models really struggle to get the details right that MOND just nails so easily. But when you zoom out to the biggest scales, like massive clusters of galaxies or the afterglow of the Big Bang, that's where dark matter is the clear winner. MOND, at least in its current form, just can't fully explain those things.
And that is the central dilemma. It's so frustrating. We have one theory that works beautifully for the universe at large, and a completely different one that works flawlessly for individual galaxies, and they're mutually exclusive. They can't both be right, and neither one explains everything. Science is basically stuck between a rock and a hard place.
But look, this isn't a failure of science. This is science in action. We are right at a major crossroads. This is one of the biggest unsolved mysteries in all of physics. And whatever the answer turns out to be, you can bet it's going to be revolutionary.
And this is not a new problem. I mean, the first hints of this missing mass stuff showed up way back in the 1930s. The problem was confirmed for good in the 70s. MOND was proposed in the 80s. And now, here we are, in the 2020s. After decades of finding nothing in the search for dark matter, MOND's freakishly accurate predictions are starting to look more and more compelling.
Honestly, this whole decades-long debate was perfectly summed up by the young daughters of two scientists who are on opposite sides of this very issue. One day, someone overheard them arguing, and one of them was yelling, "Dark matter does too exist." And the other was shouting right back, "Dark matter doesn't exist." That's pretty much exactly where the scientific community is right now.
So, which is it? Are we living in a universe that's dominated by some mysterious, invisible substance that shapes everything? Or are we on the absolute brink of discovering new laws of physics that are going to completely rewrite our understanding of gravity itself? The universe is on trial, and the verdict is still out.